Hey guys, Ms. Cologne here. I'm going to do this section into two parts. This is going to be part one. So we're going to compare proportional relationships, part one. When we're comparing a table, a graph, or an equation, you need to be careful what we're looking for and what it's asking. I apologize in advance for my voice at any point in time. So, when I'm given something like a table and a graph, but we're talking about the same situation, it is probably a better idea if we read the question first before we look at either the graph, table, or equation, because we didn't know what they're looking for. So, Sunny Orchid charges for fruit by weight. So the table shows the prices for just apples, but the graph shows you prices for your pears. So, before we answer the bottom question, we need to read what they want us to do on each end. So we need to know, first off, what is the cost per pound of apples? Meaning, if we write this out, cost per, again, means we're dividing pound. Now, in previous videos, I've told you, if you have a table, it is a good idea to label your left column X and your right column Y, because we've seen before, to find our magic number or our unit rate, you write it in the form of Y divided by X. Okay. So, Y represents your cost, where's in the numerator. X represents your weight, which is a denominator. So, we already assume this is a proportional relationship, so let's find and pick any one we want. So let's do 7 and 21 for instance. I'm going to do $21, divide that by 7. You should get $3. Now, that represents 1 pound of apples. Okay? Now I'm going to look at the graph. We need to find the cost per pound of pears. Okay? So with the pears, we need to find on the graph when your coordinate is 1, comma, whatever k is. If we cannot determine that, then that is when you need to use this formula again. So, when x is 1, I go to the line, it goes right here. Now, being that every other line counts up by 5, we're going to have to use another point and use this formula because I won't know for sure what that actual value is. So, I'm going to pick 2, comma 5. All right. 2, comma 5. Now, x is your 2, y is your 5, so I'm going to plug this value in to my formula. I'm going to do 5 over 2, and if you use a calculator and divide that, you get 2.5. So that means your cost per 1 pound of pears happens to be $2.50. So answer the question being asked, because using your unit rates is easier to answer the problem. So the question is saying which fruit is more expensive per pound. Well, we see apples are more expensive, so I will say apples are more expensive. Now, this is always an add-on that I'll ask. By how much? So if this is more, how much more is it expensive than your pears? And all you have to do is subtract. So, apples are more expensive by 50 cents. That is how you compare to answer the question. Now, we have another scenario which We're talking about ham on one side, turkey on the other of the table. Sub Club Deli sells deli meats by weight. Okay? The scale shows one customer's purchase of ham. So 2 pounds of ham is $14. The table shows the cost for common weights of turkey. So the question is, which meat is more expensive per pound? But we need to find first the cost per pound of ham and the cost per pound of turkey. Now, being that this is 2 pounds, it costs $14. I want to know per 1 pound, meaning cost per pound. So that means your cost is $14 per 2 pounds of that. But I only want to know 1 pound. So 14 divided by 2 gives you 7. All right. Looking at the weight for your turkey, because this is already proportional, it don't matter which one we pick. So I'm going to do the 2 and the $18. So again, pound per, or cost per pound. So I'm going to do cost per pound. In this case, it's 2 pounds. 18 divided by 2, 9. 1 pound of ham is $7. 1 pound of turkey is 9. Which meat is more expensive? And I want you to tell me by how much. Turkey seems to be more expensive. All right, so it's going to be turkey by how much? By $2, because I'm subtracting 7 from 9. Okay, we're going to do one more. Lily's planning a birthday party, and she's deciding between cupcakes and cookies. So, the Dotted Box Bakery charges $36 for 24 cupcakes. That's the scenario. And then the equation, y equals 2x, models the cost for cookies. So, we need to find first what is the cost per 1 cupcake, and then the cost per 1 cookie. All right. Well, if it's cost per cupcake, you're talking about cost per cupcake. Therefore, your cost is $36, and your number of cupcakes for that price is 24. So you get 36 divided by 24 on a calculator. You get $1.50. So 1 cupcake costs $1.50. All right. So now, looking at the equation is always the most easiest way to find your unit rate, your COP, your magic number. Because if my equation is written in the form y equals kx, k is that coefficient where your number lies. I already know what my magic number is here. It's 2. So how much is the cost for 1 cookie? $2. Meaning, which treat is less expensive? So if Lily's trying to save money, it's cheaper to go buy cupcakes. How much cheaper? Again, if you do $2 minus $1.50, it's 50 cents. On the next part of the video, there's going to be more examples on how do you compare either equation to a table, table to a graph, scale to a table. In order to answer the question properly, it's easier if you change all of the values to its unit rate or its COP. See you in the next video.